Welcome back to our second segment. We're still looking at classification of matter, but now we want to shift gears and look into the composition of matter. Exactly what is it that makes up matter, so that we get an understanding in terms of the physical properties that make up different materials. Right. Now, so our focus for now will be on the composition of matter. What exactly makes up matter? So we are aware that matter can either be pure substances, in the form of pure substances, or impure substances. Right. Okay. Having said that, these are the keywords that will also form part of our discussion. Microscopic particles, which is usually the physical properties, which has to do with how a material, displays certain, physical characteristics. And then we also look at microscopic particles of matter, which could relate to, the packaging of particles that make up that type of matter. Right. So these are the keywords. Now, we understand that matter is everything, or everything is matter, whichever way you choose to look at it. Okay, so matter is everything that has got mass, okay, as well as it occupies space, right? So anything that's got mass and occupies space is matter. So in other words, we can safely say that matter is indeed everything around us, right? Okay, so matter consists of particles and exists in three distinct forms, which is solid, liquid, or gas, right? So these are the forms or the states in which matter actually exists. So we are quite privy to that information, and we understand that matter can either be a solid, a liquid, or a gas, or it could be a combination of one of the three forms of matter that we have indicated, right? And then if we talk about the composition of matter, it's very important that we understand the type of packaging in terms of a particular form of matter. We can talk about a solid, we can talk about a liquid or a gas. Just to bring that into context, let's look at this simulation, which actually shows us the different forms of matter. Now, in this case, we've got a solid as an example, okay? If you look at the particles that make up a solid, they're actually vibrating within fixed position. And these particles are actually closely packed to each other, hence they actually occupy, spaces, but there's still some movement of these particles that is characteristics of any form of matter, okay? Now, let's look at a liquid, for example, okay? What is the difference? What has changed? Yes, there is still some movement, but the extent of movement in a liquid is actually greater, and these particles are actually sliding past each other. Okay, this will, in many ways, determine the properties of different substances under different conditions. Now, let's look at the other form of matter, which is a gas. Now, obviously, with the gases, you can see that the packaging is very loose, and the movement is more, is to a greater extent compared to the other two forms of matter, which is the solid and the liquid. But that's not our main focus here. It's just to understand how these particles, the microscopic view of different forms of matter under different conditions. Right. Let's go back to our discussion. Okay, so the composition is that all matter is made up of particles, okay? So all matter consists of particles, okay? That's very important. So if all matter consists of particles, and then we agree that these particles, depending on how they are arranged, it can either be a solid, it could be a liquid, okay? It could also be a gas, all right? So these are the three states or forms of matter. So we'll describe this as the state of matter, or refer to it as states of matter, right? So that's the main point that we're trying to drive home, right? Okay, moving along. So we also have what we call the physical properties. Remember the big questions that we spoke about to say what exactly informs or influences the choice of use of a particular type of material for a particular purpose in terms of application. That has a lot to do with what we refer to as the macroscopic properties, which are the physical properties that makes up that type of material. So we've got, number one, we've got the melting point of a material or a substance, okay? This is the temperature at which a substance changes, okay, from solid to liquid. So the change is actually change of state, okay? But it's still precisely the same substance, okay? And then also, here's a typical example in terms of the differences in terms of physical properties, which is the melting point. If you take, for example, ice, okay, which is water in solid form, right? Okay, it has a melting point of 0 degrees Celsius. Okay, what does that tell us? It tells us that if you've got ice, under normal circumstances, if the temperature is 0 degrees, the ice will start to turn from solid to liquid. That's exactly what we mean when we talk about the melting point. The temperature at which that substance changes its form, okay? So that temperature is 0 degrees, now Celsius. By comparison, the melting point of copper is 1084 degrees Celsius. That's way different, okay, or comparatively greater than that of ice. But there is a reason why these two actually show these differences in terms of the physical properties. We'll look into that into more detail. But the big question is, what does this melting point of a substance tell us about, you know, that particular substance? Water, 0 degrees, copper, 1084 degrees Celsius, okay? Right. And then the boiling point, which is another physical property, okay, of a substance. For now, let's understand boiling point in terms of the temperature at which the liquid changes, you know, to a gas at sea level or standard atmospheric pressure, okay? This is just our understanding in terms of the change of phase or change of state, okay? That's the boiling point. Okay? Now, melting point and boiling point of a substance is a measure of strength or how strong a substance is. So if you are given, you know, a melting point of a substance, that tells us a lot about the strength of that particular substance. So strength is actually a macroscopic property or a physical property of a material, which will also, you know, determine how we use that material in everyday life. So boiling point and melting point, there is an indication of what? Of strength of material, okay? So the strength of material, very important, okay? Right, and then let's also think about thermal conductivity as a typical, you know, physical property, okay? Alongside, we've got, you know, kitchen utensils, which is pots and pans. Now, here's a question, okay? Have you ever thought about why pots and pans are usually made of aluminum? Okay, I'll underline aluminum, while the handles are made of wooden or plastic, okay? Now, this is the big idea that we started with. We are saying that for us to have a particular material being utilized for a particular purpose, it has to speak to its physical properties. There's something special about aluminum in terms of thermal conductivity. What is that exactly? Aluminum transfers heat quite easily, okay? While, you know, plastic and wood, they're quite the opposite. So the physical property that is of interest to us at this point is actually thermal conductivity, because conductivity would vary. We can talk about electrical or thermal. In this case, we're talking about thermal, which has to do with heat energy, okay? Right, so that's the big question. And then it says here, the thermal conductivity is the extent to which a material conducts heat. So thermal conductivity has to do with heat conduction. So now, a good thermal conductor easily transfers heat. Okay, copper is used in plumbing, and it is also corrosion resistant. Okay, we don't use just steel for the plumbing pipes. Copper is corrosion resistant. It means it doesn't rust. Okay, and then a bad thermal conductor is a good insulator. Okay, this is a very important point. If a substance is a good thermal conductor, it means it is a bad insulator, in other words. It depends how you look at it, but we're still saying the same thing. And then a good thermal insulator is actually a bad thermal conductor, okay? So that's in terms of classification. Now, and we are talking physical properties, how well these materials transfer heat energy, which actually makes them fit or ideal for specific purposes in everyday life, right? Okay, and then the other thing that that we asked about this, I think we've already answered this to say aluminum is a thermal conductor, while wood and plastic are thermal insulators, right? Okay, now think about another thinking exercise. Think about the material used to make electrical wires, okay? That's its electrification, okay? What type of material is ideal or suitable, okay? And what could be the reason for your choice? Already alongside, we've got, something that we are quite familiar with in our everyday life, which is the copper wire, okay? Now, why is copper ideal for, electrical wires? Okay, that's the big question that we're asking with. Okay, now electrical conductivity is by definition a property that has to do with the material being able to allow electric charge to pass it, which is your electricity, okay? So copper wires are commonly used in wiring. Why is it so? And also around those copper wires, we've got, plastic material. Why plastic? Why copper? Okay, the idea is very straightforward. Copper is a good electrical conductor, while plastic is a good electrical insulator. Okay, so that's the main point that we want to actually address. So copper is electric conductor, and then but there's something special about copper. Okay, in some cases we need very thin wires or strands. So any material that can be drawn into fine strands without actually breaking, we say that material is actually ductile. So ductility is a property of a material that allows it to be drawn into fine strands. So it's possible with that. That makes exactly copper to be ideal for this purpose. Okay, so ductile, it means it can be drawn into thin strands or fine wires without it actually breaking. And then we've got electrical insulators that do not conduct electricity, okay? And then plastic is a good insulator, making it actually a bad electrical conductor, if you come to think of it, right? Okay, so having said that, there's also, something that, which we asked ourselves at the beginning to say, by the end of our discussions, at some point or the other, we need to be able to relate the physical property to the use, okay, and vice versa, and to say we can justify why, for example, plastic is used as an insulation, tap in electricity. Why? Because it is a bad electrical conductor, meaning it is a good insulator because it doesn't allow electric charge to pass through it. Okay, we also used an example of the pots and pans in the kitchen. Okay, but if you think of aluminium even deeper, think of it. Aluminium is a lighter material. Okay, we're gonna be looking into, in the third and final segment, into a property of density. How heavy, light a given amount of material is. So aluminium is light, it's easy to clean, it is a good thermal conductor, while the handles of the pots are actually made of, plastic or rubber. Why? Because these materials typically they do not allow heat to be transferred through them easily. So it's a combination. So there's a lot of thinking, in terms of observing, what is exactly happening around us to say, okay, the science that we learn actually exists around us. So in the third segment, we shall try and look into, more in terms of classification and, the thinking of in terms of the, the big ideas that we ask. For now, let's take a short breather.